Okay. So let's say, let's just make sure we understand this topic that we just did. Alright, so instead, I'm going to say, instead of the probability of right-handed given male, try out see if you can work that out. So you can go straight to the answer with the table. I encourage you, try doing it this complicated, the hateful way, right? The less desired route. Just try it out. See if you can get the same answer both ways. Any of you are looking to take atomic and molecular structure or thermodynamics or any, here's a listing of some science and math courses offered in the summer, or if you want to tell your friends to take statistics or papers, they want me to push these summer classes onto you guys. Okay, good. It's just time is up. Okay. Let's see. All right. What do we have? The quick answer, looking just straight from the table, we have 385 divided by 805. Okay, that's the final answer. Okay. Oh no? Male given right-handed. Okay. We'll try this. We'll try this, okay? So if we do probability of male given right-handed using A given B is equal to this and this and this, okay? This would be equal to what? Probability of male and right-handed. I'm going to just abbreviate to RH. Is that okay? Divided by probability of right-handed. Okay, all I'm doing is this. Alright, so what's the probability of male and right-handed? 385 out of 900. Right? This is everybody. Okay, we've got to be able to tell the difference between this and this. Okay, it's very important. Divided by probability of right-handed is 805 out of 900.
wording is making confusing.
There's no words.
No, I know, but like where from, what number to take from the word.
I know. Well, that's the hard part that everybody hates. Okay?
So divided by right-handed, you should still look at just the male part of the right-handed.
That's the top part. Male and
Oh,
right.
that is the total. Never mind.
Yeah.
Never mind.
The total right-handed is
Yeah.
5 out of 900.
Yeah. Thank you.
Okay. Well, put this in your notes and study it until it makes sense. There's stuff in the book as well. Okay. So we have, we'll still use this table here. And I just want to make sure we understand. Whoops. What if I ask, what is the probability of being female and right-handed? And you would tell me 420 out of what? 900. Right? There's no vertical bar. There's no given. There's no given. So this is just out of everybody. Okay.
So if it were given, it would be 470.
If it was female given right-handed, then it would be 420 out of 805. But there's no given. It's just female and right-handed, so it's out of everybody. Out of 900 people, 420 are female and right-handed.
Yeah.
Is that good? All right. What if I said, okay, so here is what's the probability that we pick someone who is female and right-handed? What if I said, what is the probability that we pick someone who is not female and right-handed?
$45 of 40.
1 minus
420 over
900.
Yeah, okay, so 1 minus 420 over 900, and that would be 480 out of 900, okay, just if you do your fractions. So, who counts as not female and right-handed?
Male.
Okay, question. All right, so there's 4 categories of people. We've got females who are right-handed, females who are left-handed, males who are right-handed, and males who are left-handed. Okay, so who is not female and right-handed? Female and right-handed, are they do not count. Okay. Females who are left-handed, do they count?
Yes.
Yes. So these count. Males who are right-handed, do they count? Yes. And males who are left-handed, they count. Okay. So who is not female and right-handed? These 3, okay? Males who are left-handed, males who are right-handed, and females who are left-handed. Alright, I'm going to put in a twist. What is, if we pick someone at random, what is the probability that this person is female or right-handed? Female or right-handed?
question for the last one.
Yeah.
Where did you get 480 from?
Oh, I just, in my head, I said 1 is 900 over 900 minus 420 over 900, and then so you do 900 minus, right? I'm just finding a common denominator, and I'm just doing the arithmetic. I'm just doing the,
Okay.
that's all, that's all, okay? So again, you know, some of us are rusty on our fractions, okay? So just,
Like this maybe?
you gotta, in this class you gotta know your fractions, you gotta know your decimals. Decimals most important, and then fractions second place. After that.
Wait, it's 480.
Is that, what?
Ah.
Is that wrong? No, that's right. You're making me doubt my own, one thing I can do is adding numbers, generally. Alright, what is our answer here? Female or right-handed? Do we have an answer?
No, okay, wait.
420.
The answer is 855 out of 900. Now how did I get that? Okay. Did I do that wrong?
Yeah.
I'm pretty sure my answer is right, but we will check. Okay. Alright. Probability, if we pick someone at random, what's the probability that this person is female or right-handed? Okay, so let's create our grid again. Okay, we have females who are right-handed, females who are left-handed, males who are right-handed, and males who are left-handed. All right. Females who are right-handed, do they count?
Yes.
Okay. Females who are left-handed, do they count? Right? Are you female or right-handed? And if you're a left-handed female, you'd say yes. Are you female or right-handed? Males who are right-handed, do they count?
Yes.
Yes. Males who are left-handed, do they count? No. Alright. So, if we add all of these up, how much do we have? We should have 855, right? We have 385 out of 900 plus 420 out of 900 plus 50 out of 900. It should be 855 out of 900.
Right.
Okay? Is that okay? Female or right-handed? Alright, that is the way to go directly from the table. We have our formula way, or equation way, which you probably won't like as much, but we go. Okay, so if we have probability of A or B, this is equal to the probability of A plus the probability of B minus the probability of A and B. Now we didn't do this at all when we did that over here, but we're going to do it now, and we will see we get the same answer. Okay, so I've got probability of female or right-handed, okay? Now in statistics, whenever we use the word or, it's an inclusive or, okay? Meaning, if I say, do you like chocolate or vanilla? The answer is yes, most likely, okay? It's people, because sometimes in English we say, do you like chocolate or vanilla? We're expecting you to say, I like chocolate, or I like vanilla. Okay, we're expecting you to make a choice. But in statistics, when we say, do you like chocolate or vanilla? We're expecting a yes or no answer here, okay? It means if you like chocolate, you will say yes. If you like vanilla, you will say yes. If you like both chocolate and vanilla, you will say yes, okay? Right, this is one of the so in English there's, I guess, I don't know, what's the word? there's a lexical gap in our English that we don't have a word to distinguish this or that or, okay? We have, do you like chocolate or vanilla? The answer is yes or no, okay? At least in statistics, when we say, do you like chocolate or vanilla, we want you to say yes or no, okay? Some people will take that as, do you mean I like this or I like this? Okay, that's a different thing. That's called exclusive or, but that's not what we do. Okay. So, is the person female or right-handed? Okay, to get this, probability of female or right-handed, we're going to do probability of female plus the probability of right-handed minus the probability of female and right-handed. Okay, all I'm doing is I'm just changing the A's and the B's into females and right-handed. We will see we get the same answer. Alright, according to our table, what's the probability that someone is female? 470 out of 900. Okay, what's the probability that someone is right-handed? 805 out of 900. Okay. Now some people, as they're doing a test or quiz, they forget this part. Okay. And if you just do this, you're going to get a number bigger than 1. Okay. And I said, if you ever get a number bigger than 1, you know you did something wrong. Okay. And so you don't forget this last part. Subtract off female and right-handed. So we subtract off what? 420 out of 900. Alright, if you do all of this math, you will get 855.
On quizzes and stuff, do you want the fraction or you want us to take it?
Either way, okay? Question?
You just do 805 over 900 plus 50 over 900?
I'm sorry?
Like right-handed people, so it'll be 805 out of 900.
Uh-huh.
And then you just do the 50 over 900.
Yeah, that works too. That works too, okay? And what you're doing there, I would argue, is you're just, you're combining this and this into one step, okay? Because essentially this 470 is made up of the 420 plus the 50. And you're saying, well, I don't want to double count that 420, okay? So that's what you're doing. And that's equally fine as well. Okay, so we have this. This is an equation that will work for A or B, okay? Is that okay? Yes?
Yes.
Another question? Yeah.
The part where, any part where it says like female and right-handed, when it's the and in the right-handed part, is that always each other?
Yeah.
Yeah, if there's no given thing, it's going to be out of everyone, okay?
So only when it says or. Oh wait, never mind.
Only when it says given,
Okay.
okay? So if it doesn't say given, just assume it's out of everybody,
Okay.
okay? All right, let's try this. Okay, what's this answer? You see that? So if we want to complicate it,
Is it 0?
I'll let you guys write that down if you want to.
Is it 0?
Huh? What is 0?
Why is that 0?
Why is this 0?
No, the
Minus zero.
Yeah, that's this one, right? Okay, let's just talk about this. Okay, probability of male or female. All right. So if I just ask you, are you male or female?
Yeah.
Your answer is yes. Okay. Are you male or female? Yes. Okay. We can. Everybody will say yes, so the answer to that is 1. Okay. If we want to use our equation, we can do probability of male or female is the probability of male plus the probability of female minus the probability of male and female. Okay. So if I say, are you male and female?
No.
Almost everyone will say no. Okay.
Yeah.
Life's a little more complicated, so about 1 in 1,000 will say yes. But male and female, generally, we say there's no one who is both, right? In most of the cases, right? There's an exception to everything, right? So yes, we do have people who are both male and female, and that's fine. But in our simplified worldview, that's how it goes, right? All right. So here I've got the probability. All right, listen up. Okay. So I got the probability of male is this, plus the probability of female is this, and I subtract off the and part, okay, which in this case is 0. Okay. So I have this. All right. That brings up a related rule, and that's for what we call mutually exclusive events. Okay. Mutually exclusive means that the and portion is 0, okay? So that there's no overlap. So we call this mutually exclusive. There's no overlap, okay? So it means no overlap, or the two events cannot happen together. Okay. So in this case, male and female are mutually exclusive. If someone is male, that person cannot at the same time be female. Okay, that means mutually exclusive. So if A and B are mutually exclusive, that means the probability of A and B equals what? 0. That's the definition of mutually exclusive. Probability of A and B equals 0. Okay? And so when we do our A or B situation, it just becomes the probability of A plus the probability of B, because the A and B part is 0. Okay? So it's just, so if we take this above equation, it's probability of A or B is equal to the probability of A plus the probability of B minus 0, so we can just leave that up there.
What if you ask right or left-handed?
Right, and so the way we have it set up, in our example, we have no overlap between right-handed and left-handed, so they are mutually exclusive. We know in real life that's not the case.
So
We have
it's
people who are
overlap.
both, there is some overlap. Not in our example, but in real life, yes, okay? And also not in our example, but in real life, there is some overlap between the male and female genders. It's just right-handed, left-handed overlap is probably much bigger than male-female overlap. But, yeah. Life is complicated, right? But that's also what makes it beautiful. So. Is that okay? So let's try something out. This is gonna be this might be tricky. All right. Okay, so we'll say let's say there are 700 students total. We will say 500 have cars, and 430 own bicycles. And 390 have both car and bike. Okay, so what is the probability someone owns a car? What is the probability someone has car and bike? What is the probability someone has a car or bike? And what is the probability someone has a car but no bike? This will, I will put a star here. This will be the bonus one. If you get that, I'll give you a bonus one. Oh, I shouldn't reveal that now because people are going to try this one before they try the other ones. Do these ones first. We'll do one more. Probability of having no car and no bike. Must use public transportation. So this one you don't have a nice handy little table anymore, huh?
I don't even have the equation.
You don't even have the equation.
Oh, there it is. There it is. No,
It should be in your notes. The table's almost never.
The first one means just cars.
Yes.
So it's
Yes. And then the second one is this one, right? It's not a given.
it's not given, so I think
So if it is not a given, it's
it's
this
390
one.
or 700.
Okay, it's not a given. So cars,
You can try making tables, but you don't. That's not necessary. And I would encourage against the tables because the tables will turn into a crutch. So So do your best. Are we totally lost?
Almost.
Almost. Don't cry. That's like the bonus. Alright, okay. Let's try this. Alright, so I think the first two, most everybody got. You just look at these. I purposely made them easy, okay? So the first one is 500 out of 700 have a car. Yay? Alright, car and a bike, I also made that easy. 390 out of 700. Yay. Good? Okay, car or a bike. Alright, so this is where we use this thing, right? Okay, so it's going to be car plus probability of bike minus what?
Car.
Probability of car and bike. Sounds okay. So car is going to be 500 out of 700 plus bike, which is what? 430 out of 700 minus 390 out of 700. Okay, and we get 540 out of 700. How's that?
Yeah.
Is that good? Okay. We have a question back there? Okay. Alright, no car and no bike. Alright, so this is where it gets a little complicated. Okay. So, alright, so we have, let's list off our categories of people. Okay, we have car only, bike only, both, and neither. Okay, so the no car and no bike is our neither category, right? Okay, is that okay? Alright, so do we know what car only, bike only, and both add up to? What is that? What does that add up to? 540 out of 700, right? Is that good? So 540 out of 700 is car only, bike only, and both. All three of those are wrapped up into 540 out of 700. So that means no car and no bike is my leftover 160 out of 700. Question. How did I get the 160? So I just did 1 minus 540 out of 700. Okay, which gives me, again, because we know fractions, this is 700 over 700. So 7 minus 540 is 160 over 700. Everyone's jockeying for vision of board. Okay, anyone want to attempt the car but no bike bonus? Let me think. I haven't even thought about it. Have cars, have both car and bike. Cars but no bike. Who said that? 110 out of 700? That is correct. Alright, so our answer is 110 out of 700. Alright, what's your name?
Saman.
Saman. Okay, bonus point for Saman. Let me, I have to write that down. Okay, remind me before you leave, and I'll find your homework and I'll put a bonus in there. Okay, car but no bike. So, Saman, do you want to explain how you got 110?
Yeah, sure.
Yeah.
So, car but no bike. So 500 has cars, 390 have both car and bike, so you just subtract it.
Yeah. Okay. So just imagine the 500 people who have cars, right? All right. 390 of those have bikes. So how many people don't have bikes? 110, right? So those are the people who have cars but no bikes. 110. Good job. Okay, so just a little bit of thinking, a little bit of reasoning, right? And we can do this stuff, all right? But you can also see why people hate this chapter. But we love it. We love it. You guys love it. My other classes hated it, but you guys love it. Okay, can we move on? Okay, let's talk about independent versus dependent events. Okay. Oh, and I erased the table I shouldn't have. Okay. Independent events, okay, we're talking about pairs of events. Pairs of events are either independent or dependent, okay? Okay, so if two events are independent, then the outcome of one has no impact on the outcome of the other. And dependent events means that there is some kind of connection. Not necessarily a cause and effect connection, but just that there is a connection between the two events. Alright. How do we know independent events from dependent events? Okay. If they are independent, then the probability of A given B is equal to the probability of A. So if A and B are independent, then this is going to be true. I'll give you guys a moment to write that down, just so we can talk about it. Alright, so these two events, if we say A and B are independent, then the probability of A, given that B has happened, is just the probability of A. Okay, so it's like B, whether B happens or doesn't happen, we don't care. The probability of A happening is the probability of A. Okay, so the probability of A happening is the probability of A, whether or not B happens. And that means A and B are independent. Alright, so let's look at two examples here. Just so we make sure we understand this. Alright, we'll do two silly examples. You got a question? Yeah.
Yeah, now you're giving examples for independent events, right?
Uh-huh.
And that's that equation.
Yes.
Just for independent.
Yes.
Okay.
Okay. Alright.
But that's the symbol for given, right?
Yes. So if A given B, the probability of A given B is just equal to the probability of A.
So meaning only when B probability is happening,
If they're independent.
right?
I don't quite understand your question. I'm sorry. It's the probability. What this is saying is that it might make more sense if we just do an example.
Okay.
Honestly, okay? Because everything feels a little more abstract when it's symbols. Well, it is abstract in symbols. All right. So let's say I don't know. Let's say we've got males and we have females, and just forgive me, we're just going to do some stereotypical thing that, whatever. Okay. We'll say watches. So what is a stereotypical thing that male or females watch?
Girls watch.
Okay, so we'll say watches sports. Okay, and then does not watch sports. Okay, alright, so we will say, let's say there are 400 males, 600 females, and let's say 240 over here, and 280, so that leaves 120, and 360. So we have male, female versus watches sports and does not watch sports. And then over here I'm going to do another one. Corrective lenses, so glasses or contacts, and no corrective lenses. Okay, so now we will explore if these events are independent or not. Okay, I'll let you guys copy down your tables first. So when you got all your numbers written down, just look up here, so I know we're ready to go on. Or play on your phone. Also works. Alright, okay. So we shall move on, and so we want to know, alright, is watching sports independent or dependent of your gender? Okay, so sports watching is that independent or dependent of gender? Okay, well, if they are independent, the probability of A given B should equal the probability of A. Alright, so let's just try one of these out. Okay, so let's call watches sports A. Let's call this A, and we will call male the B. So what is, so I'm going to do probability of A given B, is that equal to the probability of A? So probability of A given B would be probability of watches sports given male. And this, if they are independent, we want to check that to see if is it equal to what? Probability of just watches sports. Okay, well you have the table, so you can just go with the table style answer rather than trying to do all the formulas, okay? Alright, so what is the probability of watches sports given male? Huh? 280 over 400, right? Okay, so make sure you can do this. Probability of watches sports given male is 280 over 400. So we see that. Right. What is the probability of watches sports? 520 over 1,000. We also see that. Okay. So the question is, are these two equal? Okay. Well, this is where you have to pull out your calculator. What's 280 over 400? 0.7. What's this? 0.52. So is 0.7 and 0.52 the same number? No. Okay. So these are not the same. So, are they independent or dependent?
Independent.
They are dependent.
Oh, dependent.
Not the same means dependent. Okay? This is only true if they are independent. If they are independent, then this is true. But this is not true, so that means they are dependent. Can we see that? Okay. I will give you guys a moment to let that sink in. And if you have questions, raise your hand. Yes? I'm sorry? So the numbers are not the same, so that means they are dependent, or they are not independent. Okay? If they are independent, then the numbers will be the same. If they're the same, that means they're independent. If they're not the same, they are dependent.
Yeah.
Good? Alright, so let's look at this one, okay? So, alright, is corrective lenses, so that glasses or contacts, are there other corrective lenses? Monocles? Okay, so whether you wear glasses or contacts, is that independent of gender? Okay, is corrective lenses independent or dependent of gender? Okay, so if they are, we're going to check what? Probability of A given B. So again, you just, have to pick a couple things. You label one to be the A, so I'm going to choose this to be the A, and I'll choose this to be the B.
And it doesn't matter.
It doesn't matter,
Okay.
okay? If I want to call this the A and this the B, that's fine. If I want to do female rather than male, also fine. It doesn't matter, okay?
Checking the
Because
data.
as long as you choose one of these rows to be A and one of the columns to be B, this will work, okay? Or you can do one of the rows to be B and one of the columns to be A. It doesn't matter. But just for, I guess, consistency, we'll do this, okay? So this is probability of corrective lenses given male. And is that equal to the probability of corrective lenses? Alright? Alright, what's the probability of corrective lenses given male? 240 Alright, 240 over 400, great. And what is the probability of corrective lenses? 600 over 1,000. Okay, you pull out your calculators, and this turns into a decimal, and what is that equal to? 0.6, and this turns into a decimal, 0.6. Okay, so in this case, these two numbers are the same,
Independent.
so that means they are independent. It's very important that you set these up correctly, okay? Because if you try to do corrective lenses given male versus probability of male, it'll blow up. It won't work, okay? Or if you do probability of corrective lenses given male versus probability of no corrective lenses or something, okay, it's not going to work. So remember, it's A given B. Is that equal to the probability of A? That's the thing you use. So I always find it helpful to label one of these as A and B and go on from there. Okay, so make sure you understand these examples. You will definitely see something like this on next week's quiz. Okay, I'll give you a table and I'll say, are these things independent or dependent? So make sure you know that example, okay?
Is this our fourth rule?
Huh?
Is this our fourth rule?
Our fourth what?
Rule that we've done tonight?
I don't
You don't
number
know.
these
Okay.
rules, okay?
Never
I know
mind.
the concepts I gotta cover, I just go with those, okay? How many topics have we covered in our class so far? Yeah, there's no way to keep track, right? Oh, here's a question. If two events are mutually exclusive, are they independent, not independent, or could go either way? If two events are mutually exclusive, are they independent, not independent, or could they go either way?
Either way.
Independent. If two events are mutually exclusive, they are definitely not independent. They're definitely dependent. Okay? Why? Remember, independent means the outcome of one has no effect on the outcome of the other. Okay? If they're mutually exclusive, that means when one thing happens, the other cannot happen. Right? So there's definitely a link, right? If this thing has happened, this cannot happen, right? So if I pick someone at random and I know this person is male, that person at the same time cannot be female, okay? Independent means the probability that this person is female has nothing to do with whether or not this person is male, but that's not the case, okay? All right. One more thing. Okay. Sequences of independent events. this will be our last topic for the day. And I got 22 minutes. Okay. And there will be a couple questions on next week's quiz that deals with sequences of independent events. Okay? So, sequence of independent events. If we label the events, okay? So let's say our sequence is A, then B, then C, then D, etc., 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 okay? The probability of A and then B, or we just call this A and B, is equal to the probability of A times the probability of B. Okay? This applies only when A and B are independent. So if A, B, C, and D are all independent, then the probability of A and B and C and D all happening, okay, so this is A, then B, then C, then D, is equal to the probability of A times the probability of B times the probability of C times the probability of D, and so on, okay? So you can expand this to as many sequences, or as long of a sequence as you need. Okay? So probability of A and B is the probability of A times the probability of B. Again, this only applies when A and B are independent. Okay, so let's try out a very simple example. All right, so let's say we flip a coin 3 times. Okay, each coin flip is independent of So that means anytime you flip a coin, it has nothing to do, the outcome of the coin flip doesn't depend on anything else that has happened. Okay, you could see 5 heads in a row, and then the next time you flip a coin, the probability of getting heads is going to be 50%, right? Okay, so I'm going to ask, what is the probability of getting heads, heads, heads? So for one flip, I think we already know this, but I will put it on the board. For one flip, the probability of getting heads is 0.5. So what's the probability of getting heads, heads, heads? 0.125, exactly. Alright. So the probability of heads, heads, heads is equal to 0.125. Now how did we get that? This is equal to the probability, just like we have up here, is going to be the probability of heads times the probability of heads times the probability of heads. 0.5 times 0.5 times 0.5, which gives us 0.125. I'll let you guys let's, I'm gonna try something. Alright, what is the probability of getting heads, heads, tails? So the sequence, heads, heads, tails. Do we see it's the same thing, 0.125? Because it's 0.5 times 0.5 times 0.5, okay? Not clear to anyone? Raise your hand. Okay, I'm going to change this up. What is the probability that after 3 flips, a total of 2 heads and 1 tail? This one's a little different. Alright. So just think for a moment. A total of 2 heads and 1 tail. So that means after 3 flips, we need 2 heads and 1 tail. So there's actually a few ways this could happen, okay? One way is we get heads, heads, then tails. Another way is what? Heads, tails, heads. And another way is tails, heads, heads. Is there any other way I can get 2 heads and a tail? No, this is it. Alright, what's the probability of this one? So each of these have the same probability of 0.125, right? Is that okay? Each of these sequences are mutually exclusive from each other, right? If I see heads, heads, tails, if my 3 flips is heads, heads, tails, I couldn't have at the same time have gone tails, heads, heads. So these are mutually exclusive. So 3 flips where we get a total of 2 heads and 1 tail is this, or this, or this. I'm going to add these 3 together, and I get 0.375. That's the probability of getting a total of 2 heads and 1 tail after 3 flips, okay? But not necessarily in that order.
You add them. Why do you add them? Because they're not, they are mutually
Because
exclusive or they're
these,
not?
each of these are mutually exclusive, right? Because it's what is this or this or this? Okay, it's a probability of this or this or this.
So then they're now dependent.
Well, they are not dependent. I mean, it's their sequences. Okay, each flip is independent. Okay, but then the entire sequence is not independent of the other sequences. Okay,
And
it's we've got 2 different things going on. Each individual flip is independent of the other flips. Okay, but then at the end of the day, when you look at the 3 flips together, they're not independent of other things that could have happened. Okay, so don't complicate it too much. Just I think you just add these 3 up and say that's all that can happen.
But you came to that conclusion just by writing it out and thinking it through.
Right.
That
We'll
there's
talk
only-
about. This is actually called the binomial model, which we'll cover in more detail next week. But this is our introduction through probability rules. All right, hang on. I know we're almost over here. Okay, but we just have a little bit. Okay, so let's say instead of flipping a coin, let's say we're gonna do. Let's say we have a die, okay? We've got a die. One, two, and three. What's the probability I roll the number 4? 1 out of 6. Okay? Let's say I roll the die 4 times. Okay? These are a few questions. What's the probability I get the sequence not 4, not 4, 4, then not 4. Okay. What is the probability that after 4 rolls, no 4s at all? Now, what's the probability that I get at least 1 4 after 4 rolls? Okay, let's tackle each of these one at a time. I rolled the die 4 times. What's the probability that I see this sequence where the first one is not a 4, the second one is not a 4, the third one is a 4, but the last one is not a 4? Okay, this is going to be the first. It's a sequence. 5 out of
6
times.
5 out of 6.
5 out of 6 times.
1 out of 6.
1 out of 6 times.
5 out of 6.
5 out of 6. Excellent. Okay, so that's some number I don't even want to bother. Oh, I can't do it. Okay. 125. What is this? 36. 192. I can't do it. I don't know what 36 squared is. It's too much. It's too hard. I can't do it. Okay.
1296.
What is that?
1296.
1296. Great. Thank you. Okay, after 4 rolls, what's the probability that we see no 4s at all? No 4s at all. Okay, how do we do that? Alright, so for this to have happened, what had to have happened the first time? Not a 4. Okay, so this is the same as not 4, and then the second die had to be not a 4, and then the third roll had to be not 4, and then the last one had to be not a 4. Okay, so that, if we can break it down like this is easier to figure out, right? This just becomes 5 out of 6. Can I just do raised to the 4th power?
Yeah.
Okay, great. 625 out of 1296. Or whatever decimal that turns into. Okay, at least 1 4 after 4 rolls. This is the trickiest, but not really. So to get at least 1 4 means I could have seen, no, don't jump there yet, okay? So I rolled the 4 die 4 times. Now, what's the most amazing thing that could have happened?
All 4s.
All 4 of them were 4s, okay? But then, so I could see 4 4s. I could also see 3 4s, or 2 4s, or something else, okay? Or 1 4, right? So at least 1 4 means I could see 1, 2, 3, or 4 4s, right? So qualifying is 1, or 2, or 3, or 4 4s. Okay.
Four thing.
What's the only thing that will not satisfy this? Zero fours, okay? So, as long as I do not end up with not 0 fours, okay? So as long as I don't end up with 0 fours, that means I got at least 1 4. What is the probability of not 0 fours? 1 minus the probability of 0 fours. And what is this 0 fours? 1 minus 625 out of 1296. Is that okay? So this turns out to be 671 out of 1296, some decimal, doesn't matter, okay?
Wait, where's the formula? I mean,
There's no formula.
there's no formula. Oh, it's just what you figured.
Yeah. So this is all thinking.
Right.
Alright, which is probably why students hate it. They're not used to this requirement. Alright, okay. So the key here is whenever you see at least one something is the complement of none of that thing. So at least one is the complement of none. So you can join the I have at least one yacht or the I have no yachts club, right? So you either have at least one or you have none. Those are the only two possibilities in the world. It's like this. You either have at least one of something or you have none of that thing.
And what's complement again?
Complement is the opposite thing.
Okay.
It's the not that thing.
Not that complement.
Alright, you guys have a quiz next week, and so we'll see you then.